Hey there, for this activity on antibiotic resistance, make sure you have a highlighter, any color, doesn't matter. I'm going to be using yellow, but you will need a highlighter for this activity. So I have already cut and glued this out into my notebook, so I'm ready to go ahead and get started. So we've been talking about the immune system and viruses and how different pathogens can influence natural selection, right? Or one of the mechanisms that can lead to evolution or a change in a population over time. Well, antibiotic resistance, right, is one of those mechanisms that can influence natural selection, right, or whether or not, right, certain bacteria will survive or die. So there we go. I think that's a little bit better. Okay. So an antibiotic, okay, is any substance that kills bacteria, okay, or at least severely inhibits their growth. Let me zoom in a smidgen there. Is that better? I feel like it's out of focus. Okay. So when you are exposed to a pathogen, if you get sick, you can only use antibiotics if that pathogen is bacteria. If it's a viral infection, antibiotics aren't going to do anything because they only kill bacteria. Okay? When bacteria are not killed by an antibiotic, we say they are resistant. Okay? So antibiotic resistance, the bacteria is resistant to this substance that we're trying to kill them. So antibiotic resistance can be described as natural selection in bacteria, right? Selecting who survives, right, and who doesn't. So let's take a look at how antibiotic resistance occurs. So bacteria grow and multiply very quickly, which means that mutations often occur in their DNA. Okay? And these mutations cause genetic variation. Right? And we know that in order for natural selection to occur, you have to have variation, either variation of genes or of your phenotype. Remember, you have to give nature something to select. So let's say we've got a mutation, right, in this bacteria right here, okay, some random mutation, okay. So some of the mutated bacteria may become resistant or not affected by the antibiotic. The bacteria that are not resistant to the antibiotic, they'll die, okay? But the bacteria that are resistant, right, they'll survive. So we took an antibiotic, it killed, 99% of, the bacteria that were causing our infection, but this one, right, it's still alive, right? And that's not good. The resistant bacteria will reproduce and pass on their mutation to the next generation. And this is really bad because again, we're still infected. Sorry, I'm struggling here. There we go. Bacteria, right, they reproduce by asexual reproduction. So their offspring will all be identical. Right? So this means that the offspring will also be resistant to the antibiotic. So now all of these bacteria are resistant to that antibiotic. And so I now have basically an antibiotic resistant infection, right? Which is really bad because I can't, I'm still sick. I can't get better. So we have to be very careful when we take antibiotics to, number one, make sure that we actually need them, right? Do we have a bacterial infection or is it viral? but to also make sure we take the medication as we are told to by our doctor so that we actually kill all of the bacteria and we don't create any bacteria that become resistant to that antibiotic. Also, antibiotic resistance can happen simply because we have used that antibiotic over and over and over again, not just you or me, but as a population of humans. And it causes that antibiotic to be just less effective. For example, penicillin. It was so widely used. Every time someone had a bacterial infection, penicillin, right? That was our go-to. Today, it's basically useless. A lot of us are now allergic to penicillin, and it's just not prescribed as much because the bacteria that used to be killed by it just simply aren't anymore. Um, so again, right, antibiotic resistance is a good example of natural selection in bacteria, right? You got that random mutation that allowed some bacteria to survive, right, while others were killed, right, leading to a change in the population of that bacteria, evolution. Um, the same idea here for antibiotic resistance can also be applied to pesticide resistance, pesticides that we spray on our crops to kill bugs. The exact same principle, right, can be applied there. Okay, so hopefully this activity helped give you a better understanding of how antibiotic resistance and pesticide resistance are examples and mechanisms of natural selection. So if you have any questions or concerns, just let me know.